So from the previous slides, we're going to learn about PN junction bias. What is the p-type matriars? What is the n-type matriars? From here, we're going to learn about the bias and bias PN junction operation. It's really basic principle of the operations. Okay. So one more time, the PN junctions is the boundary or interface between two types of semiconductor matriars. One is the p-type, the other one is the n-type. Okay. So usually p side contains an excess hole, while is the n side contains is the excess the electrons in the outer shells of the electrically neutral the atoms. Okay, now, so maybe as I said before, PN junctions is operated so bias is like a forward bias and reverse bias. So first over, we're gonna learn about forward bias. So forward bias from figure 5, you can see that when switching is on in this circuit, the conduction band electrons in the antimaterial are pushed toward the junctions. Okay, so means, and also the valence band holes in the p-type material, okay, also are pushed toward the junction. What does that mean? Right there, hole is the push, and also the push, the minus the electrons in the antimaterials. So for this case, maybe in other words, the negative potential is applied to the antimaterials right there. And the positive potential is also applied to the p-type materials, okay? So that is we're going to call as the charge motion at this moment when switching system is closed. So what is situation? So what happened in here? So if they steal the push from the battery of the two different side, positive, negative, the push, the p-type antimaterial, some point, the electrons in the antimaterial, the breakthrough, the depletion, the layer, go there. When? Assuming the forward voltage, V sub F, is greater than barrier potential of the junctions. This is very important. It's greater than the barrier potential of the junctions, okay? So it depends on materials. When the forward bias PN junctions begin to the conduct, so the silicon is 0.7 volts and germanium is 0.3 voltage, okay? So one more time. So when a forward bias PN junctions begin to conduct, forward voltage across the junction is slightly greater than the barrier potential of the junction device value, V sub F. It depends on approximately 0.7, 0.3 that have operated. The conduction increase as depletion layer, maybe after depletion layer breakdown, okay? So after that, they make the bulk resistance, the electron free to recombine with the holes in the p-types matter and conductions, the occurs. And each type materials make a register, okay? But how about the reverse bias, the PN junctions? For this case, PN junctions is reverse bias when the applied potential causes the antimaterial to be more positive than the p-type materials. And also PN junction reverse bias when applied to the p-type materials. It's like so that was the depletion layer become the wider, the junction current is reduced. Finally, they come to 0. What does that mean? From the battery, the plus and minus side, the push here, that was more electrons the outside from the junctions of the depletion layer, right? And also the plus positive in the p-type materials, attraction here, attractions. The 2 point has attraction means the depletion layer positive and the hole in the maybe antimaterials, and then p-type materials electrons wider depletion layer. Okay, wider depletion layer means that the junction current should be decreased, reduced, the almost 0. So no current here. Okay, that is the two type of the concept of forward reverse bias. So to summarize, the forward the p-n junction bias to make the minimization of the resistance, the junction resistance. So that is increase the junction current. While if the PN junction was reverse bias, the junction resistance maximized to reduce or minimize the junctions, the currents in the reverse bias cases. Okay.